Hello everyone, let me start by introducing the key objective and highlights for our treatment plant project. The main objective of this system is to ensure that water purification is safe, reliable and efficient. We aim to maintain optimal level of several key variables including flow rates, chemical dosing such as alum and chlorine, pH level and turbidity. These are critical for producing clean and safe drinking water. Next, for the system design highlights, our system uses multi-variable control to manage complex and interdependent processes. It relies on real-time data to support smart and adaptive decision making. This helps the system handle disturbance effectively and improve overall performance in terms of stability, efficiency, and consistency. The last one is regulatory and safety compliance. Our design follows the standards that set by WHO and the EPA. It ensures the delivery of safe drinking water and environmentally safe discharge. The system is developed with a strong focus on sustainability, public safety, and technical excellence. Now we will move to explain the detailed process of how the system works. Now let's move on onto the process description of our water treatment plant. The treatment process starts with raw water intake, where water is collected from a river, lake, or reservoir. It is then passed through a screening system to remove large debris like leaves and branches. Next, we have a coagulation and flocculation. In this stage, chemicals such as alum are added to the water to bind small particles together and forming larger clumps called flocks. The water then flows into a sedimentation tank where these flocks are settled at the bottom due to the gravity and allowing clearer water to rise to the top. Following that is the filtration process where the water passes through layers of sand, gravel or activated carbon, and this step removes remaining particles and improves clarity. And after the filtration, disinfection takes place. Chlorines or other disinfectants are added to kill harmful microorganisms and ensure the water is safe to drink. Finally, the treated water is stored in a clean water tank before being distributed to homes, businesses, or other end users. This entire process is continuously monitored to maintain high quality and compliance with health and safety standards.
Assalamualaikum. My name is Muhammad Bahagia bin Azman. My metric number is B1323101071. I present about safety, legal, environmental consideration. First, complying with WHO, EPA and national standard is essential to ensure water safety and avoid legal or reputational issues. Second, chemical dosing must be carefully controlled. Overdosing chlorine or alum can create health risks and damage equipment. Three, safe handling of chemical like chlorine requires proper ventilation, leak detector and safety system. 4. Environmental protection is critical. Spill or untreated discharge can harm ecosystem and lead to severe legal consequence. Last, risk mitigation involve regular audit, monitoring system and emergency protocol. Okay, next, control system design. The objective of control system design is maintain turbidity below limits for clear water. Second, keep pH and chlorine level within safe ranges. Third, control tank levels to prevent overflow or pump damage. Last, ensure steady flow rate to match demand and prevent pressure issues. For the manipulated variables is chemical dosing rate, pump speed for flow and pressure control, valve position to manage inlet or outlet distribution, Adjustment made dynamically based on real-time data. For the disturbance, first change in raw water quality, demand fluctuation, daily seasonal variation, last weather impact or rain or drought affecting water characteristic. For the measure variable and instrument, we choose the pH transmitter, turbidity meter, third chlorine analyzer, 4 ultrasonic flow meter, 5 radar level sensor, and last pressure transmitter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We'll be presenting about the instrumentation. So, for the instrumentation, we got 3 points, which is instrument selection and calibration. And then the second one is instrument identification, which is PNID symbols. And then the last one is transducer installation. So for the instrument selection, we have pH sensors, turbidity meters, and flow meters. So pH sensors are calibrated with buffer solution, and then turbidity meters are calibrated using Formazine standards, and then the last one is flow meters are calibrated via volumetric or gravimetric methods. And then for the PNID symbols, we have FT, flow transmitter, and then PT is pressure transmitter, LT level transmitter, and AT analyzer transmitter. So next, for transducer installation, first one is inline setup, with chief flow and turbidity sensors, and then submersible or radar for level measurement. And then the last one, we need to ensure accessibility for calibration and perform routine maintenance. Okay, next for installation cost. For instrument, we have pH transmitter, turbidity meter, ultrasonic flow meter, radar level sensor, and pressure transmitter. So for pH transmitter, the cost 3,290 ringgit. For turbidity meter, 6,815 ringgit. And then for ultrasonic flow meter, 8,460 ringgit. For radar level sensor, 5,875 ringgit. And then the last one is pressure transmitter, 3,760 ringgit.
To conclude, a multi-variable control system play a crucial role in ensuring that water treatment process achieve the required standard for quality, safety, and environmental protection. It enables real-time monitoring and control of key parameters such as flow rate, chemical dosing, pH levels, and turbidity, ensuring the treated water remain consistent and safe. With the help of calibrated sensor and smart control mechanism, the system can quickly respond to any disturbance in the process, maintaining stability and performance. This level of precision helps water treatment facility comply with international standards set by organizations like the World Health Organization and the Environmental Protection Agency, contributing to the protection of public health and the environment. In addition to improving reliability and operational efficiency, this system also supports long-term sustainability. It represents an important advancement toward intelligent, safe, and adaptive control system in modern water treatment.